When educational institutions confront generative AI, they tend to focus on the immediate threat, the cheat sheet problem. Administrators pour concrete over the issue, building policies to block access. Meanwhile, users ignore the pavement, carving their own routes through the grass. Internal data reveals that roughly a third of educators are already using AI casually. They translate materials, generate lesson plans, and summarize reports. An invisible, unregulated workflow is operating right beneath the surface. Urban planners have a name for this phenomenon. They call it a desire path, the organic, user-driven trails that form naturally before city officials decide where to lay the actual concrete. Education systems cannot resolve AI adoption through top-down bans. To formalize this technology safely, schools must observe these educational desire paths. They need to analyze how the technology is already being applied to map out a functional infrastructure. Rogers' diffusion of innovation theory explains this gap. Conservative institutions are, by design, late adopters. The early adopters mapping the desire paths today are the educational technology companies, driven by competition to test at scale. To understand what a mature integration looks like, we have to look past the classroom and examine how these tech companies take chaotic user habits and build a structured architecture. That architecture relies on three distinct tiers. The first tier is the product. This is the specific tool or environment where the student interacts with the machine. The second tier is the pipeline. This dictates how educational content is manufactured, structured, and legally monetized. The third tier is the ecosystem. This encompasses the institutional policy, the pedagogy, and the cultural environment supporting the staff and students. Systemic AI integration requires re-engineering all three of these architectural tiers, the product, the pipeline, and the ecosystem, simultaneously. At the product level, we can look at Yandex, an early adopter, testing educational AI at scale. They develop digital textbooks to teach complex subjects, like Python programming, to beginners. The primary technical hurdle with student-facing AI is hallucination. Large language models predict the most likely next word, rather than calculating the truth. They act like a highly confident friend who often gives incorrect answers. In education, the machine has to be accurate. A student working on a coding problem at 1 a.m. has no human teacher to ask for help. Yandex deploys an AI tutor to bridge this gap, ensuring the student isn't blocked by a simple syntax error. To make this interaction safe, students never write a raw prompt to the neural network. When the student clicks a button asking why their code is broken, that input passes through an invisible filter. The system attaches complex, hidden pedagogical instructions to the query. It tells the LLM, "You are an 11th grade tutor. Do not give the direct answer." To increase accuracy, this model is fine-tuned using thousands of real-world mistakes submitted by 11th graders. The machine learns the exact patterns of novice errors rather than relying on clean, synthetic data. Even with strict prompting, the system requires an ethical gatekeeping layer to ensure safety before it ever communicates with the student. The primary LLM generates a response, but it is not shown to the user immediately. First, it is audited by a secondary neural network for pedagogical safety and accuracy. Only then does the student see the message. An open-ended ChatGPT window is a raw utility that can bypass the learning process. The Yandex model is a structured educational product. At the product level, effective educational AI hides its own complexity and constrains its capabilities. The design protects the pedagogical process. Stepping back from the student experience, we reach the back-end economics of course creation, the pipeline. This is where institutions manufacture their curriculum. A common misconception is that AI is simply a brainstorming tool for authors. This view misses the structural disruption to the supply chain. In the traditional pipeline, a subject matter expert writes the first draft. This creates economic bottlenecks. Because the expert owns the intellectual property of the text, institutions get locked into complex royalty agreements. Updating a few videos in a large course becomes a contractual nightmare. The platform Lectorium implemented a pipeline flip. Generative AI absorbs the baseline writer role, drafting the foundation of the curriculum instantly. Human roles elevate in this new structure. Subject matter experts are high-level editors and color commentators. The institution pays the expert a flat fee to verify the AI's work and add personal insights, while retaining full copyright of the base material. This economic restructuring allows institutions to update materials in weeks rather than months, shifting the economic viability of digital education. This speed introduces a pedagogical risk: the destruction of context. Standard search engines and language models often deliver immediate, shallow answers, bypassing the deep framework students need to grasp difficult subjects. The pipeline must utilize an AI bibliographer model. Instead of summarizing a fact, the AI curates a learning environment, guiding the student to long-read articles, historical texts, and video lectures. Take a specific subject, like the post-flight life of Yuri Gagarin. An AI bibliographer can guide a student through a structured, long-read course, maintaining the rich historical context rather than reducing his life to a list of bullet points. At the pipeline level, AI facilitates a restructuring of educational labor, making deep context curriculum viable to produce at scale. With the curriculum built, we reach the ecosystem, the daily management of teachers, students, and administration within institutions like the Letovo School. Administrators generally choose between 4 strategies. They can offer free choice, they can issue strict mandates, they can refuse or encourage stimulated use. Mandates typically breed formal compliance. Refusal is ineffective against students who will simply walk the desire paths on their own devices. Stimulated use is the optimal path for conservative institutions. This relies on peer-to-peer adoption supported by administrative scaffolding. In this ecosystem, a studie's introduction to AI begins with academic integrity. They learn that taking information from a machine and presenting it as their own is a violation of that integrity. Next, they are trained in critical evaluation. Students are shown how AI hallucinates data and invents fake bibliographies. They learn to scrutinize the output rather than accepting it as fact. Only after mastering integrity and evaluation is a student introduced to the mechanics of prompt engineering. For teachers, the ecosystem uses AI to eliminate administrative drudgery. Instead of spending hours manually compiling end-of-term progress reports, teachers use AI to synthesize their notes with the school's central database. This centralization allows the AI to scan datasets to identify predictive failure models. It flags a student who is slowly drifting off track before they actually fail a class. At the ecosystem level, successful integration establishes a culture of critical integrity before teaching the mechanics of the tool. A functional modern educational architecture requires hidden guardrails at the product level, flipped labor models at the pipeline level, and a culture of critical integrity at the ecosystem level. But designing a system this automated brings up a persistent anxiety. Does this level of efficiency mean the human teacher is eventually engineered out of the system? The machine has strict limitations. It excels at generating baseline content and spotting data anomalies, but it operates without personal stakes. The AI scans the dataset and flags a predictive failure model. It tells the school exactly which student is about to fall behind. But it takes a human teacher to look at that data and execute a localized personal intervention. Motivation requires personal connection. A student cares about the answer because they care about the environment, and personality requires character. Foundational theory anchors this point. Konstantin Ushinsky observed that only a character can form a character. A machine can transmit data, but it cannot impart values. An AI tutor may answer a late-night coding question, but it cannot inspire the student to care about the answer in the first place. The definition of a teacher is evolving. They are moving away from being the primary distributors of raw information. Teachers are high-level editors of generated output and personal architects of student motivation. Re-engineering the system with AI clears the path for human character to remain the central focus of education.